Hello everyone, welcome to this channel. This question is from chapter 2, multiple choice question number 36. The question is, a large parking space has uniform slope of angle theta with the horizontal. A driver wishes to drive his car in a circle of radius r at constant speed. Coefficient of static friction between the tires and the ground is mu. What greatest speed can the driver achieve without slipping? Assume entire load of the car on the front wheels. So we have to select the correct choices from the given options. Let us solve this question. So this one is your large parking space. This parking space is making an angle theta with the horizontal. A driver wishes to drive his car on this circle of radius r. The whole load of the car is assumed to be on the front wheel. Coefficient of friction is given as mu. The driver has to drive the car with constant speed, but it should be maximum for that radius of the circle. So let us consider the forces. So we have taken 4 points, A, B, C and D. At this point, at point A, if you see the force along the slope or directed along the slope is maximum, that is centrifugal force plus component of the weight of the car. At other place like B, it is not only mg sine theta is working in this direction. Here also at this is mg sine theta is working. Here also it is mg sine theta is working along the slope. So this is the place where the force that can push the car downwards is maximum. So for this will be the point where we should consider all the forces and check for the maximum speed what the car can achieve. So we have made a free body diagram at point A. N is the normal reaction force Fc plus mg sine theta. Fc is the centrifugal force. Mg sine theta is the weight component in this direction. Mg cos theta is the component of force along the normal of the surface. Since because of this force there will be a tendency to slip in this direction, so friction force will be just opposite, and for it there should not be any slip. For that this force should be equal to this, or we can say that along this direction the net force should be 0. So this is what we have written here. We have put the value of centrifugal force. We have assumed that the V is the maximum speed with which it is going constantly in this circle. So Fc will be mv square by r plus mg sin theta minus mu1 is equal to 0. Along the perpendicular direction of the slope, there is no acceleration or no motion because the car is all the time intact on the surface. So in this direction also, the total force will be, the net force should be 0. So from there we got N is equal to mg cos theta. Now we will compare equation 1 and 2 and put the value of normal reaction and centrifugal force. So then we will be getting this expression, and finally V is equal to square root of G capital R in bracket mu cos theta minus sin theta bracket closed. Option D is having this value. So our answer will be D. Hopefully you understood how this has been solved. In case of any doubt, please do write in the comment box. I will clarify the doubt. Thank you.